In this video, we are going to find internal resistance of a cell using potentiometer. It is the second application of potentiometer. The first application was to compare EMF of two cells using the potentiometer, and now this is to find internal resistance of a cell using the potentiometer. This is a circuit diagram that would be used to find internal resistance of a cell. This is the potentiometer, this is the driving circuit, this is the cell of which you have to find the internal resistance. This is the resistance box. Now the working goes like this. In the first step, what you have to do, you have to switch or plug in the key K1 and K2 is left open. So what happened? The current flows through the potentiometer wire, and then you have to find the null point, right? And you know how to find a null point. You just have to slide the wire, you just have to slide the jockey on the wire, and the null point is that point where there is no deflection in the galvanometer. So suppose you get that length by L, so that is L. And when the circuit is open, when the key is open, this is the EMF, that is the EMF, right? That is the difference between EMF and potential difference. When the circuit is open, the potential at that time is called as EMF. So according to principle of potentiometer, that is E is proportional to L. So in this case, E would be proportional to L, and you will get the first equation, that is E is equal to KL. Now in the second step, what you do, you choose a suitable resistance from the resistance box, and after choosing any resistance, that is the external resistance, you plug in the key K2, right? Now the current flows. Now this cell is also in the circuit. Now this is involved in the circuit. Now you again find the null point, and suppose you get the null point at L1. Now at this time, when the circuit is closed, it is not EMF, it is the potential difference of the cell, that is V. So V is proportional to L1, or V is equal to KL1. This would be your equation number 2, that V is equal to KL1. Now if you divide both of these equations, you get E by V equal to L by L1. This is your third equation. But see, you have to find internal resistance of a cell. Now in few videos back, when we were discussing about internal resistance, we derived a formula of internal resistance, that was small r was equal to E by V minus 1 multiplied by R. Now if you substitute the value of E by V, that is L by L1, so you get the formula R equal to L by L1 minus 1 multiplied by R. So by knowing the value of R, resistance box, this would be known, and finding the positions of null point in both the cases, when open circuit and in closed circuit, that is L and L1, you can find the internal resistance of a cell.